Hi, Algebra 2. This is a review, or the answers for the third quarter review of chapters 6, 8, and 9. So I know period 3, we did a few of these in class the other day, but I'm going to start from the beginning. Whenever you're factoring, the first thing that you're going to look for is a GCF. So that first problem has a GCF, A does. I'm going to factor out a 5x. You have to look at the numbers and the letters. When you factor out a 5x, you're sort of dividing out that 5x. I'm left with 2x minus 7. You can quickly just distribute in your head just to make sure that when you do that, if you were to multiply them, it would give you back that original problem. B is an example of difference of two perfect squares. All right, there is no GCF, but you should be checking for that each time. I set up my parentheses. 25 is a perfect square, 4 is a perfect square, and y squared is a perfect square. So my factors are 5 minus 2y and 5 plus 2y. They're exactly the same, except the sign in the middle is different. Number 3, the third kind of factoring after you look for a GCF or difference of two perfect squares is just going to be that trinomial. Now, if there is a coefficient of 1, it's fairly easy. If there's a number in front, then you're going to use that AC method. So I multiply 5 times negative 6 is negative 30, and I'm looking for the factors of negative 30. That will give me a positive 13, and that is positive 15 and negative 2. So I rewrite that middle term of 13x as positive 15x and negative 2x. And you can see now that I have 4 terms, and I'm going to do the GCF with the 2 terms on the left. I'm going to factor out a 5x. I'm left with x plus 3, and then I'm going to do the GCF with the 2 terms on the right, and I'm going to factor out a negative 2, and I'm left with x plus 3. So my factors, those GCFs that you pulled out, becomes one set of binomials, and then the other factor is that common binomial that they had. All right, and D is an example where you're going to have to factor completely. So I'm going to factor out a GCF of 4, and I'm left with 2x squared minus x minus 3. And then that 2x squared minus x minus 3 can be factored to 2x minus 3 and x plus 1. 2 is a factor by grouping. You can see that there are 4 terms there. So again, you're factoring the 2 terms on the left, GCF, you pull out an x squared, you're left with 3x plus 4, and then I'm factoring the 2 terms on the right. I pull out a negative 25, and I'm left with 3x plus 4. Notice that the binomials that's left have to match. That's one of the factors. And then those GCFs that you pulled out, they become the other binomial. This one, though, has another kind of factoring because x squared minus 25 is the difference of two perfect squares. It factors to x minus 5 and x plus 5. All right, when we're solving, you're going to solve by factoring. Some of you prefer to use the quadratic formula, and that's perfectly fine to do. I used the AC method here, so I multiplied 2 times negative 24 was negative 48. And then I was thinking of the factors of negative 48. That gives me a negative 13 here. And those factors are going to be negative 6x and positive 3x. And then again, I'm factoring by grouping. So you can see those 2 terms on the left. I factor out a 2x, and I'm left with x minus 8. And the 2 terms on the right, I factor out a 3, and I'm left with x minus 8. So 2x plus 3, the GCFs that I pulled out become one factor, and the x minus 8 is the other factor. Okay, and then I just set each factor equal to 0, and I solve. So my answers are going to be x equals negative 3/2 and x equals 8. All right, so this one I want to place the quadratic in vertex form and identify its turning point. So what I do is I take these first 2 terms, the 4x squared plus 24x, I factor out a 4 from them, and I'm left with x squared plus 6x. The 15 I sort of shove off to the side for a second. And then I have this x squared plus 6x, and I have to say, all right, I take half of b and I square it. So half of 6 is 3. 3 squared is 9, so I'm adding 9. I'm completing the square here. I'm not really adding 9 though. I'm adding 4 times 9. And remember, whatever you do to the right, you have to do that same thing to the left. So on the left, I'm also going to add 4 times 9. What I'm doing is I created this right here. What I created is a trinomial that factors to x plus 3 squared. All right, and the 4 times 9 that was on the left, the 36, gets brought back over to the right by subtracting it. And then you can see I'm just combining the 15 and the negative 36 to give me negative 21. And then this is vertex form. My turning point right here is negative 3, negative 21. Right? You have to remember to change the sign on that term that is next to the x. All right, focus in a directrix, and the parabola is smack in between of them. So you can see I have a focus of 3, 1, and my directrix is y equals 7. So my turning point has to be right in the middle of them. My turning point is going to be at 3, 4. All right, turning point is halfway between the focus and the directrix. This parabola has to face downwards, right? It cannot face the other way. If it was facing this way, halfway between, it would be crossing the directrix, and that is not true. The parabola, the definition, it is halfway. Every single point is exactly equidistant from the focus and the directrix at the same time. Just to remind you how to write an equation, something you probably did on the delta math practice. The formula is y equals 1 over 4p x minus h squared plus k. Now remember, the h and the k are just my turning point. All right, so that I have right here is 3, 4. The p is the distance from that turning point to that focus right there. So p is equal to negative 3. And all I'm doing is substituting that in. 1 over 4 times negative 3 is negative 1/12. So there you go. You can write an equation of that parabola. 6, I'm solving the square root equation. So remember, I have to isolate that radical. I'm subtracting 19 from both sides, and I get 30. I got to get rid of that 5, so I divide by 5. Once you isolate the radical, then you're going to square both sides. Now the squaring and the radical cancel out, and I'm left with x minus 4 on the left. On the right, I have 6 squared, which is 36, and I add 4, and I get x equals 40. Properties for exponents. When I'm multiplying, I add the exponents, so the numerator, I get x to the 8th. Now I'm dividing, and when I'm dividing, I subtract exponents, so my final answer is x to the 4th. For b, everything is to the 3rd power. So negative 2 to the 3rd power is negative 8. A power to a power, you are multiplying. 5 times 3 is 15. And I just noticed I forgot to do the y. So remember, the y squared is also to the 3rd power. So this should be y to the 6th. Sorry about that. 8, I'm going to simplify radicals. So the 25 breaks down to radical 25 and radical 3. X to the 9th breaks down to x to the 8th and x. Everything I have highlighted in yellow is a perfect square. Everything I have highlighted in green is not a perfect square. So the 3 and the x will stay under the radical. Radical 25 becomes 5, and radical x to the 8th becomes x to the 4th. Cube root, same idea, but the cube root of 16 breaks down to the cube root of 8 and the cube root of 2. And the cube root of y to the 14th, I want the highest exponent that's a multiple of 3. So that's going to be y to the 12th, and I'm left with y squared. Again, anything in green is not a perfect cube. It's staying under the radical. Anything in yellow is a perfect cube. The cube root of 8 is 2. The cube root of y to the 12th is y to the 4th. When you're doing your exponents, I can't combine them unless they have the same denominator, those fractions. So I make them all have a denominator of 6, because I notice that the bottom has a denominator of 6. So I make it x over 12 to the 6, x over 2 to the 6. On top, I'm multiplying, so I add those exponents, and I get x over 14 to the 6. Now I'm dividing, so I subtract those exponents, and I have x over 9 to the 6. 9 to the 6 reduces to 3/2. They want me to write my final answer in simplest radical form. So I'm going to put that fractional exponent back as a radical. Remember that denominator is the root and the numerator is the exponent, but I can simplify this, so I'm going to simplify it over here. The square root of x to the third is x squared and the square root of x squared is x. All right, 10 is just an easy quadratic formula. So a is 2, b is 3, c is negative 20. So it's negative b, negative 3, plus or minus b squared, which is 3 squared, minus 4ac. Everything under the radical I put into my calculator, and that actually gives me 169. So it's the radical 169 is 13, so it's basically negative 3 plus 13 over 4, and negative 3 minus 13 over 4. So my two answers are 5/2 and negative 4. Here I want to solve, so I bring that 100 over to the right. It becomes negative 100. I divide by 2, and I get negative 50. And then I have to take the square root of negative 50, which is the square root of negative 25, and the square root of 2. And just be careful on this, because a lot of you are leaving the I under the radical, and the square root of negative 25 is 5i. The I is out of that radical. And there are two answers, a plus and a minus 5i, radical 2. 12 is just an adding problem, so I'm going to add the numbers, the real numbers. That gives me negative 4. I have them highlighted in yellow. And I'm going to add the imaginary numbers, and I have those highlighted in green. B is a FOIL problem, so 5 times negative 3 is negative 15. 5 times negative 7 is negative 35i. 4i times negative 3 is negative 12i. And 4i times negative 7i is negative 28i squared. Now 35i and negative 12i can get combined together to negative 37i. And remember that I squared equals negative 1. So negative 28 times negative 1 is positive 28. And that just gets combined with the negative 15 to give me positive 13. Here you're just doing the quadratic formula again on 13. So a is 1, b is 4, and c is 58. My answer, though, I'm going to have to put in a plus bi form. So when you simplify all that, under the radical, notice I'm getting negative 36, and the square root of negative 36 is 6i. So it's negative 14 plus 6i, and negative 14 minus 6i over 2. Since all of those numbers are even numbers, they're all divisible by 2. Negative 14 divided by 2, actually let me fix that. That should be a negative 7. And negative 7 plus or minus 3i. All right, and the last one, I just want to find the discriminant. Remember, my discriminant is b squared minus 4ac. The discriminant doesn't tell me the roots, but it tells me about the roots. This discriminant is 76, so that means that my roots are real, but they are irrational, okay? And so, yeah, I'm not sure why I wrote rational here, because 76 is not a perfect square, so they should be irrational. Okay, so I have two unequal irrational roots.